All right. Welcome, everyone. My name is Casey Wang. I'm a co-PI on the Fabric project. Thank you all for joining us today for the seventh installment in our Mastering Fabric Tips and Tricks webinar series. Today, it'll be led by Komal Thareja. Next slide, please. Before we begin, I'd like to share a few housekeeping items. The webinar will include a live question and answer session following the presentation. Please note that the chat feature of Zoom has been disabled. So if at any point you have a question, please go ahead and type it into the Q&A box at the bottom of your screen, and we will answer them during the Q&A session. Finally, the webinar is being recorded and will be shared with all the registrants. Next slide, please. We're happy today to be joined by our presenter, Komal Thareja. Komal Thareja is a senior distributed systems software engineer at RENC and a graduate student pursuing a master's in computer science degree at North Carolina State University. She serves as the lead software architect and developer across multiple projects supported by the U.S. National Science Foundation, including Fabric. Her expertise spans database applications, cloud orchestration, IaaS, distributed systems, and scalable computing. Komal plays a pivotal role in designing control software for next-generation networks and experimental testbeds like Fabric. She is a key contributor to Jupyter examples for interacting with Fabric, the user-facing API called FabLib, and has created several artifacts available on Fabric's Artifact Manager. Before her work in scientific computing, she gained extensive corporate experience in architecting and implementing applications within the scope of mobile and communications industry. I will now pass on to Komal to start the presentation.
Thank you, Casey. Hi, everyone. Here's a quick overview of what I will be covering in this talk. I'll start with a brief overview of the Fabric testbed, just to set the stage for anyone who might be new to the platform. And next, we'll talk about a common challenge users face, why some of the resources may be unavailable when you need them, and then dig into the specific causes of the unavailability. From there on, I'll walk you through how to query resources effectively and introduce the concept of advanced reservations, what it is, why it matters, and how it can improve the success rate at which you can acquire resources on Fabric and run your experiments. We'll then look at what happens after you have requested resources in advance, covering the allocation outcomes and the provisioning phase, and how these processes can impact your ability to renew existing slices. Finally, I'll also highlight the advantages of advanced reservations, followed by a brief summary and the best practices to help you get the most out of Fabric. So let's dive in. What is Fabric? Fabric is a mid-scale research infrastructure which gives researchers a sandbox environment to prototype and test their experiments in a widely distributed network before you are ready to deploy them in production. Fabric has a huge worldwide footprint with 35 sites, which are interconnected by dedicated network capacity with 100 Gbps links shown in blue here and 1.2 terabit links shown in yellow. We not only have footprint within US, we also have several sites available in Europe like Bristol, CERN, and then in Asia like Tokyo. In addition to all these locations, we also have a facility wherein you can connect Fabric to existing facilities or testbeds like Cloud Lab or Chameleon. In fact, we are also connecting. Fabric is connected to University of Chile via facility port at FIU. This slide highlights the variety of programmable resources which are available on Fabric that users can leverage for their experiments. Starting with networking, Fabric offers both layer 2 and layer 3 connectivity. At layer 2, you can create or set up wide area circuits across multiple sites. At layer 3, Fabnet provides global IPv4 and IPv6 connectivity between nodes. We also support dedicated smart NICs, including ConnectX-5 and ConnectX-6, which enable offloading and high-performance packet processing. We are in the works to introduce Bluefield DPUs as well. So stay tuned. In terms of storage, users have access to both local disks and dedicated NVMe PCI devices, which are ideal for high throughput workloads. Additionally, there's this concept of persistent network storage volumes, which are available, wherein you can save your data, which you want to save across your slices. For compute accelerated workloads, Fabric supports a range of GPUs, including NVIDIA RTX 6000, Tesla T4, and A30, allowing users to run AI, ML, or other GPU accelerated applications. We also provide FPGAs, specifically Xilinx U280, which are ideal for custom hardware acceleration and low latency processing. A recent addition is Tofino programmable switches, specifically the Wedge 100 BF32X, which support P4 programming for highly customized data plane experiments. Lastly, Fabric also offers facility ports, like I showed in the previous slide, which are basically layer 2 or layer 3 connections to external testbeds and facilities like Chameleon, Cloud Lab, and others. These allow for federated experiments and broader integration across platforms. Altogether, this resource diversity makes Fabric a powerful and a flexible environment for a wide range of research domains, networking, AI, ML, systems research, and many more. So, what is one of the common challenges users face when they're trying to use Fabric? It is most often the desired resources are not available when they need it. This can lead to unexpected delays in starting your experiment, especially when your slice requires more demanding or specialized components. In many cases, these delays are due to insufficient availability of basic resources like CPU, cores, RAM, or disk space. But the issue becomes even more pronounced when requesting specialized hardware like smart NICs, GPUs, FPGAs, Tofinos, which are fewer in number and often in high demand. Let's look at some of the potential causes behind this. First, the resource you're trying to reserve might already be in use by another user, or it could be held by a long-running slice. Secondly, it's possible that there is a heavy demand on certain popular sites. Like for all the sites you see on the TerraCore link, they're very popular among the users, and it's almost always impossible to get resources there. So understanding these constraints is essential for better planning and can help guide us towards solutions like advanced reservations and querying availability more strategically. A recent and a very useful addition to the Fabric portal is the ability to perform time-based queries for resource availability. This helps users to plan ahead by checking whether the resources they need will be available at a specific future time. So So what we did, I'm at this point, I'm going to switch from my slides to the portal and show you how you can query for resources based on time. So I'm right now on the portal. On the top left corner, you see resources. If you click here and then click on the resources overview, you can get an overall idea of what resources are, how many resources we have, how many sites we have, but there is no way for you to know when a specific kind of resource would be available. If you click on a specific site, you get specific site details, but if you log in, you would be able to do specific time-based queries as well. So now I'm logged in. Let's go to resources and resources overview again. Um, let's say if I'm trying to request resources on New York website. So let's click on the site here. And here in you can specify, choose a time range. For example, I want to request a slice with ConnectX 6, dedicate SmartNICs. And as you can see right now, I need, and for my experiment, let's say if I need two of them, if you can see only we only have 3 total, and 2 of them are already in use. So my slice would definitely not be accepted on New York if I did that today right now. But based on choosing a different time from this, like if I selected a start time and an end time here, I can try and find out when would these resources be available. So I specify a start time and an end time, and then click refresh. This query is a bit expensive, so it takes a while for it to return the response back, but it gives you information about when would those resources be available. While we are waiting for this, let me go back on the slides and show you how uh, this is again a snapshot of what I did on the portal. Let's wait for a, oh, okay. So it looks like my time window I specified was 15th of April from now to 2nd of May. Even then, I can't find 2 SmartNICs. So they have been requested for that longer duration. But you can change the interval here and request the availability again to find out when would these resources become available. Let's go back to the slides. So in addition to the portal, users can now query resource availability directly from the notebooks, which is great for more programmatic workflows. So not only from the portal, you can also find out about the resource availability from the Jupyter Hub. Now, this allows you to define a custom time range for your query and whether you're checking the availability for later today, next week, or a recurring window. And you can preview the resource availability programmatically without having to manually go to the portal and check every time. Like I checked before, it wasn't available for the next 15 days. So instead of going back to the portal again and again, you can do that programmatically through your API, through our APIs. This is especially useful if you're developing repeatable experiments, building automation pipelines, or want to dynamically select resources based on the availability. It brings flexibility and control right into your code environment. On the right, if you see, I have a snapshot of an artifact, which allows you to do that. I'm also pointing the link to the notebook here. Let's go to the Jupyter Hub and see how I can query this. You can go to the Jupyter Hub directly through this link, or you can go to the Jupyter Hub from here as well. It takes you both to the Jupyter Hub from the portal. Like from the portal on the top, we have a Jupyter Hub menu. Just click there. Let me log in. Okay, I am logged in. When you're logged in, there would be already either of these directories, Jupyter examples release 1.8.0 or Jupyter examples main. So let's go to the release 1.8.0 example. In here, you have this directory called a notebook called start here. And then we have this notebook here called explore fabric artifacts. So if you click here, and let's run this, it opens the notebook, which shows all the artifacts we have available on Fabric. While we are waiting for this to run, in the meanwhile, I also want to show you, this is Fabric's artifact manager. I'm logged in, so it's only showing my artifacts as on the front page. But if you click here, all the artifacts which other users or Fabric team has published are available, can be viewed here. We recommend that you explore these artifacts. We have several examples available. They're very useful if you're new to Fabric or if you're an advanced user. It could be a good idea to look at what other people are doing. Let's go back here. Here On the Jupyter Hub, you can see that there are two, you can search. Let's say I wanted to do list resources, so let me do resources. Yeah, so this is the first notebook that pops up, list available resources. You can click download and that artifact would be downloaded for you. And let's go back to the work directory. And here you can see that I have this directory called list available resources, like that was shown here. You can just step through it and find out the notebook. And as shown on my slide deck, we're looking to open this list all resources notebook. Let's go here, list all resources notebook. This notebook shows various ways how you can query resources on Fabric programmatically. So I'm not going to run through all the cells because it takes a while for, this is an expensive call. It takes a while for the responses to come back. So I'm going to just go through where I was trying to show querying resources based on time, which is what this webinar is about. So herein, what you can do is you can choose a time interval. In this case, for example, I'm trying to say 1 day from now, what is the availability of resources for next 24 hours? So you just choose the time range here by specifying a start time and an end time, and then invoke this called list sites by passing in the start time and then end time, and it would return back the availability of all the resources. If you have used this before, you know that it returns a huge table of all the kinds of resources available on various sites. While we're waiting for the response, I also want to highlight that if it is possible, oftentimes we are not wanting to know all the resources. We are more concerned about the specific kind of resources we want for our slice. In that case, you can filter the response from the list sites and look for only specific resources you want. For example, if I'm looking for, if I want to find out how many codes are available on a specific site or how much RAM does it have, and if I'm looking for specialized components like ConnectX 6 or ConnectX 5, you can specify only those specific kind of fields and then query only for them. So it takes a bit of a time for the response to come back. So now the response for the original query is back. So these are the resources available in that time window, like starting from tomorrow and the day after, and until day after. Yeah, looking at this huge table could be daunting because you'll have to scroll down on the left and the right to figure out what were you looking for. So that's why I prefer doing the filtered response. In that way, you can quickly look for the resources you were interested in. And the response is much tailored to your request. So let's just give it a couple of seconds and it'll be back. While we're waiting, I can even show you. Oh, sorry. This is like I have a snapshot of how the response looks like. So in this case, I have filtered on specific things I was looking for, like how many codes are there, how much RAM is available, how much disk, and whether the ConnectX 6 are available or not. So this is what you can see on a filtered response. Sorry, yeah. So we got a similar response on Jupyter Hub here. Okay. Moving on. Fabric also now supports advanced reservations, allowing users to reserve resources ahead of time. A huge benefit for planning experiments around specific timeline or scarce resources. So, so this is trying to address all the issues you could run into if the resources you were interested in were not available. So here is how it works. So you can specify a time window up to like 15 days in advance to indicate when you want your experiment to start. And then define the resource lifetime, meaning how long you need the slice for. This can be set in hours depending on your experiment's needs. And when you're defining the time window, you could use the response. Use the response from your previous list resources query to figure out what your time window should be. And then once you have defined the time window and the resource lifetime, then simply create a slice request with your desired resources as you normally would. The system will check for availability during the selected window and hold the resources for you if a match is found. This is especially useful for coordinating team-based experiments, reserving specialized hardware, or aligning with scheduled demos or events. So once you submit your request with the time window and resource requirements, the system evaluates the availability and proceeds as follows. If the resources are available, your slice will move to allocated OK, and the individual slivers will be ticketed. The least start time will be set to the latest available time within the requested window. So it's important to plan your window carefully if the timing is critical. That's why querying the resources based on time is critical, because that helps you choose the right window. However, if the system can't find enough resources that meet your criteria, you'll receive an insufficient resources error. In that case, you can adjust your request by expanding the time window, selecting a less busy site, or reducing your resource requirements, and then try again. This phase ensures that the resources are reserved only when they're truly available, helping to prevent overcommitment or provisioning failures. So in this case, if you look at on the top of the slide, on the right side, I have a slice in which I requested the slices. I requested the slice in future, and the resources were available, and hence the slice moved to allocated OK state, and the individual resources are ticketed. And in the second example shown here, um, the resources I requested were not available in the window I chose, and in that case, I got back insufficient resources error. I know the screen display looks a little bit blurred, so I'll run through the notebook and then you'll be able to see the exact output. Let me go back again to Jupyter Hub. Um, Again, on the artifact manager, this time we want to do advanced reservations. So let's search for that. If you search for advanced reservations and then click on download, um, it would be download the corresponding artifact and the notebooks would be downloaded. And let's go back to the work directory, and you can see it says the directory's name is validate and submit slice. So let's open that. There is this advanced scheduling notebook here. Let's open that. Again, this notebook runs through very similar steps, importing the library. If you want to query resources, for example, in the example I have here, I'm trying to request a slice with two ConnectX 5s. So that's why I'm trying to query whether the ConnectX 5s are available or not. I'm going to skip this. Okay, let me run this. So this is the start time I'm looking for, like tomorrow. And then I'm trying to get for about an, oh, okay. I think I have a mistake here. That's why I was thinking, why my start time and end time show the same? Sorry. Yeah, so I'm looking for resources between tomorrow and the day after. So from April 16th to April 17th, let's query them. While we are waiting for the response for that, let me walk you through the rest of the notebook. So I basically just set the parameters, slice name, what kind of node names I want to use, what kind of network, and which specific sites are of interest to me. In this case, I'm trying to request a component of ConnectX 5. So let's run through this. Again, in here, I need to specify a time window for my slice, and this could be really useful. The output of list slices could be list sites could be very useful for me to determine this window. So if in here, if it shows that resources are available on April 16th to 17th, then that could be the time I specify here in this duration. And if they show as unavailable, then I can change the time accordingly. I'm going to run through this notebook so that we're not waiting longer for this. So I have I'm assuming that the resources may be available next tomorrow and until the day after tomorrow. So let's see. And I have specified how long I want the resources for. In this case, it doesn't have to be days. You can specify this in hours. So I'm only requesting them for 6 hours. And my window is between April 16th and April 17th. Then I create the slice like I normally would. I create a network. I add a node, and I add a component which is connected within a ConnectX 5. Set up the IP addresses for that. Again, add another node, add a component, ConnectX 5, configure the IP address for that. In addition to adding the nodes and the network, one additional thing I'm doing here is I'm adding these post-boot execute instructions. These instructions help me specify tasks for my code to be executed when the VMs become actually when the VM becomes actually active or when they're actually provisioned. So I don't have to go and log in to the VMs when they actually are active. These tasks can be executed like by itself. So that's why I add these post boot tasks. So once the VMs are up, these tasks will be executed. So you can plan your experiment in such a way that if you script it well, you just tell uh, as soon as my reservation becomes current, run these steps or launch my experiment. In this case, what I'm doing is I'm installing the required software and trying to run a Docker container, which has some of the Fabric tools we have installed and running iperf between the two nodes. Okay, like I was showing, in this case, I got lucky and the resources I was requesting are actually available, which is ConnectX 5. So my slice went to an allocated OK state and individual slivers are in ticketed state. If the resources were not available, this slice would have failed and I would have gotten an error, insufficient resources here. And the slice would have been in a closed or a dead state. So this is the next piece of code is optional. You don't have to have it. But since I added post boot tasks, which are the tasks which would be executed once your VM becomes is provisioned, you can run these tasks. You don't want to run them from the Jupyter Hub containers we offer because the Jupyter Hub container we offer has a timeout. If you haven't used it for 24 hours, it would be restarted and it would lose the session. So we recommend that you either run it through a script running from your own remote station, or you launch local Jupyter Hub containers. We have instructions on how you can launch local Jupyter Hub containers here available. So what it does is basically it is polling and it's going to wait for my VMs to come up. And once the VMs are up, it will execute all the tasks I indicated here in the post boot execute and run my experiment without me manually going back to the VM and running my experiment. And then I can later on check my results. In this case, like you can see, it's going to wait for this many seconds because my slice is going to become current only tomorrow. So if you can't have this running on this Jupyter Hub container because my Jupyter Hub container would be culled in 24 hours due to inactivity. Let me go back to the slides to walk you through this as well. So now that my slice is in allocated okay state, what happens? Let's find out what happens when another thing. Let me go. One more thing I wanted to point out here is, as you can see, the least start time for my slice is April 16th and 7:25 p.m. So what happens when that time becomes current? Let's find out. So at the least, when the least time start time becomes current, the system transitions your slice and slivers to active state. The slice status changes to stable okay, and the slivers move to active. So you'll also receive an email notification letting you know that your resources have been successfully provisioned and are ready to use. To streamline this process and eliminate the need for manual checks, um, and taking an action, waiting for that email, and then going back and logging into the VM and then running your experiment. We recommend using automation strategies like post-boot tasks, as shown in the notebook I just walked you through, which allow your experiment to automatically begin as soon as the slice becomes active. And this is ideal for hands-off operation and works well in advanced reservations. Alternatively, you can run your experiment from a Jupyter Hub local container or a custom script. This script can use a wait loop that monitors the least start time and then triggers your experiment when the slice is ready. Another important note I want to highlight here is that if something goes wrong during this provisioning phase, such as network setup failure or device configuration issue, or um, the control framework failed to attach the component, it'll show up as a normal provisioning error. And it's important to note that these are different from resource availability errors. So by the time the provisioning begins, resources have already been reserved for your slice. So these errors are about setup or configuration, but not about the availability. And if you do run into any provisioning errors, the usual troubleshooting tools and the logs apply. Please reach us out on the forum, and we would love to help you. Another important aspect of advanced reservations is its impact on the slice renewal. When you're working with advanced reservation, it's important to keep in mind how they can affect slice renewal. If you try to renew a slice into a time window where those same resources are already reserved by another user, the renewal will fail due to a conflict. In other words, your renewal might be blocked if the system can't secure the same resources again for the extended period. So unlike before, where renewal was kind of always guaranteed, uh, you have to watch out for the slice renewal now. If you're reviewing your slice via Jupyter Hub, renewing your slice via Jupyter Hub, Fabric will notify you immediately. And if the renewal fails because of an advanced reservation conflict, you'll get an error message that the reservation could not be extended. And this early feedback gives you a chance to take corrective action, like adjusting the renewal time, modifying the resource request, or even reserving a different set of resources. Being aware of these potential conflicts can help you avoid disruptions to your experiments. So I'll conclude with the benefits of advanced reservation. Um, First, I mean, it enables planned experimentation. You can reserve resources ahead of time to align with your project deadlines or demo schedules. It helps you reduce wait times by avoiding the uncertainty and delays of on-demand provisioning, especially during busy periods. With advanced scheduling, you gain improved predictability. You'll know exactly when your resources will be available, which helps with planning and coordination. It also promotes efficient resource usage. By using time-based queries, you can target low demand periods, increase your chances of success. And for complex setups that require scarce or specialized components like GPUs, FPGAs, um, or SmartNICs, booking in advance gives you much better chance of securing what you need. It's also automation friendly. You can integrate these scheduling features into scripted workflows, especially when working from Jupyter Hub or notebooks. And finally, it helps you avoid interruptions during renewal. Like awareness of future reservations ensures you don't get surprised by renewal failures when other users have booked resources in advance. Overall, advanced reservations make your experiments more predictable, efficient, and scalable. That's all I have. I have another slide which just gives a brief summary of what we talked about. Um, that's all from my side. Thank you.
Right. Well, thank you, Komal. So now we'll just hop right into the Q&A session. We will begin with questions submitted during the presentation. Now we can stop screen sharing to begin addressing the questions. So the first question, my experiment requires changing the kernel from generic to low latency variant and configuring CPU isolation for systems, which requires rebooting the nodes. Can I add the reboot command as a post-boot task?
Yes, you can do that. And one key point to note, remember, is that when you do the all the network configuration Fabric does is done using the IP commands, and they are not reboot persistent. But there is a way, when you have rebooted your server and it comes back, there's a API called node.config. So remember to have a loop in your post boot tasks to invoke that too. So for nodes, for n in slice nodes, invoke node.config. I can share that snippet with you, but it is possible to do that. I can point you to an example where we have that.
That's great. The next question, what happens if the resources I reserved become unavailable at provisioning time?
The resources are kind of guaranteed. When you requested a resource is in advance, if the resources are not available, they would not be allocated to you. So if you have a slice which went to an allocated OK state, they are already reserved for you. And when your reservation time becomes current, they would be allocated to you. There is no overcommitment.
Thank you. And also for those that are new to Fabric, remember there's a Fabric forum where a lot of your questions can be discussed there. And that's where when Komal said that she can provide you with more examples, once you post it to the forum, then we can follow up from those from the forum. So the third question, will the use of advanced scheduling be policed in some way to prevent users from monopolizing resources, even if they are not used?
Um, we have I mean, I have an open work item to address that. We know that the moment we rolled this feature out, we also thought that is something users could do. We are working on addressing that, so it would be coming soon.
Thank you. Question number 4. Can I modify or delete an advanced reservation?
Yes, you can delete an advanced reservation, and since you don't have any active slices, active resources yet, you can't really modify it. You can delete it and then create it again.
That's great. The next question, how far in advance can I reserve resources?
The time window you specify is a 15-day time window. It can start from tomorrow, it can start from 1 hour from now, or it can start 1 month from now. So your window, the length of the window has to be 15 days, but the window can start at any time based on your needs.
Thank you. The next question, can I reserve specific components like GPUs or FPGAs?
Yes, just like you request any kind of resources today with your slices, if your project has permissions for those specialized components or specialized resources, you would be able to request them with advanced reservations too.
The next question. Considering the level of global presence Fabric currently has, are there considerations for universities outside the US to use Fabric? And if yes, what are the requirements for partnership? This is a question from University of Benin, Nigeria.
I think we do have collaborations with universities outside United States too, but this would be more for a Casey question to answer how those collaborations work. Sorry for passing on the baton, Casey.
Sure. Please feel free to connect with us. If you can send us a message, we will follow up with you. There are different ways that we can collaborate. Thank you. So with that, I think that's all the questions we have today. Now we will come to a closing. Thanks again for our presenter, Komal Thareja. In addition to our presenter, we would like to also acknowledge the behind-the-scenes team. There are several of us worked diligently to bring this webinar to production. So right here, we can see on the slide, in addition to myself, we have Chelsea Davis, our project manager, Jayshree Jagannatha, our social media specialist that really help architect the webinar. Next slide, please. Thank you for all the audience for your participation in today's webinar. So in addition to sharing the recording of this webinar, we will also email everyone who has registered with a list of resources. So right here on the slide, you see some of those resources. From this slide, you can connect with us, and then you can find a lot more resources regarding Fabric and the topic today. So we hope that you will reach out to Fabric for more questions and discussions. Our next webinar will be Stitching Together Innovation with Fabric Users on May 20th at 3 p.m. This is a different webinar series that will be focused on new users. We would really appreciate it if you could forward this information to relevant users in your communities. And as a final reminder, if you are a Fabric user, we strongly encourage you to submit your Fabric matrix to describe your project, your research. Your project description in the portal is also very important. If you keep it up to date, we can use that information to promote your research, and we will use that for outreach and post some of your materials on our website. So thank you again. Hope you enjoyed the webinar and have a wonderful day.